Today we're going to work on simplifying, multiplying, and dividing rational expressions. What are rational expressions? A rational expression is a ratio or fraction that has a polynomial in both the numerator and the denominator. How do you simplify a rational expression? A rational expression is simplified if it has no common factors. So if you are asked to simplify a rational expression, you need to factor both the numerator and the denominator and cross out the factors that are the same. Now, you are able to cross out these common factors if the same polynomial is in both the numerator and the denominator of a fraction. Then that factor reduces to 1. We also are going to be focusing on excluded values. What is an excluded value? An excluded value is a number that when substituted into the polynomial that is in the denominator of a fraction gives you 0. Remember that if you have a 0 in the denominator of a fraction, then the fraction is undefined. We need to make sure that we do not use an excluded value or excluded values when we are asked to solve an equation that involves rational expressions. Let's practice simplifying rational expressions. Example 1. 3x squared minus 7x minus 6 divided by x squared plus 2x minus 15. To start this simplification, we need to factor both the numerator and the denominator. Now, there are two ways to factor. I know some of you do guess and check. Others of you do the X method, which is splitting the middle term. I'm going to focus on guessing and checking. So when you are guessing and checking, your job is to look for two values that multiply to 3x squared. Well, 3 is prime. So the only way to get that 3 is 3x times x. Now, when we are looking at the 6, you can either multiply 1 times 6 or 2 times 3 to get that number. Let's try some different combinations. I'm going to start with the 2 and the 3. Suppose we put the 2 as the second term in the first binomial and the 3 is the second term in the second binomial. Let's see if this combination of numbers gives me my middle term of negative 7x. So when I look at this product, I have 2x and 9x. Now, this operation is telling me that 1 is plus and 1 is minus, or 1 is positive and 1 is negative, and the larger of the two is negative. So 1 is positive and 1 is negative, the larger is negative. So that means this one's going to be my positive, this one's going to be my negative, and if I add down, I get a negative 7x. And that is what I want. So I'm happy with that number combination. Here's my positive for my 2x, here's my negative for my 9x. Now, we're going to do the same thing with the polynomial in the denominator. I have my product of my two binomials. I'm looking for two values that multiply to x squared. So that's going to give me an x and an x. Now I'm looking for two numbers that multiply to 15. So if I'm looking at that 15, my options are 1 and 15 and 3 and 5. I'm looking for two numbers that multiply to negative 15, but when you add them or subtract them, you're going to get a 2. So I'm going to look at this combination. Let's say I put the 3 and the 5 in this position. This product is going to give me 3x, and this product is going to give me a 5x. Looking at these operations, one has to be a positive, one has to be a negative. The larger of the two needs to be positive. So the larger of the two is the positive 5. Here's my negative 3x. So checking that sum is going to give me a 2x, which is what I wanted, a positive 2x. that will put my negative in front of the 2 and my positive in front of the 5. All right, let's erase my check. All right, now your job is to simplify this rational expression. Well, when I look at the values, the x minus 3 is a binomial that repeats. So anytime you have a number over itself, for example, 6 over 6, I know that that reduces to 1. It's the same situation here. If you have an x minus 3 in the numerator and that same binomial in the denominator, those terms would reduce to 1. So my final simplified form would be 3x minus 2 all over x plus 5. Let's look at a second example. In the numerator, I have a difference of squares. So to start factoring that binomial, I know I'm going to have an x plus 2 and an x minus 2. Now let's focus on the denominator. The denominator has 4 terms. And when you have 4 terms, your job is to group. So I'm going to group the first 2 and the second 2 and take the GCF out of each. So when I'm looking at the first 2, that greatest common factor is 2x squared. That's going to leave me with an x minus 2. Now, not quite sure what I'm supposed to take out of the second pair, but I better be left with an x minus 2 as my binomial. So if I look at these 2 terms, each one of these is divisible by 5, so 5 is going to be my greatest common factor. To finish this off, I look at my repeat between my 2 terms, which is x minus 2, which means this is also a greatest common factor. X minus 2 is that common factor, which would leave me with 2x squared plus 5. So I now factored that polynomial into x minus 2 times the binomial 2x squared plus 5. Now, same idea when I'm reducing. I'm looking for a term that is in the numerator and in the denominator. If you look at this combination, I have my repetition, that is x minus 2 over x minus 2, and I can reduce those because that ratio reduces to 1. So my simplified form is x plus 2 in the numerator and the binomial 2x squared plus 5 in the denominator. Now, you can use parentheses or not. Since it is just 2 binomials, I really don't need it. This is where the fun begins. Let's multiply 2 rational expressions. Now, a rational expression is a ratio of 2 polynomials or a fraction that contains a polynomial in both the numerator and the denominator. So my main task, again, is to factor. You are going to be a rock star after working with rational expressions. This trinomial in the numerator, my 2 is prime. So that's going to give me a 2x and an x. I'm now trying to get factors of 4, a combination of which is going to give me a 7x. I'm going to place the 4 in this position and the 1 in this position. Now checking my factoring, that gives me a 1x and an 8x. I know that 1 is going to be positive, 1's going to be negative, and the larger of the 2 has to be negative. So when I'm looking at that, the larger of my 2 is the 8x, and when I find the sum, it gives me a negative 6x. So that positive is going to go in front of the 1, and the negative is going to go through or in front of the 4. Let's erase this check. Now, same process, working with the denominator. 3 is prime, so I know I'm starting with a 3x and a 1x. Now, I need to keep in the back of my mind that I'm going to be reducing these ratios. So I always want to consider the fact that I might be looking for a match. Well, Let's look at factors of 8. I have 1 and 8, and I have 2 and 4. Again, this combination needs to give me a 10x. Let's say I put the 4 here and the 2 here. Now, one of the reasons I was thinking about using this combination is in the numerator up here, I have an x minus 4. And maybe it is possible to get an x minus 4 in the denominator as well. Let's try. If this is going to be a minus or a subtraction, and this is going to be a plus or an addition, let's see if that combination works. This product is a 2x, this product is a negative 12. And if I add them together, that gives me a negative 10, which is what I wanted. Very exciting. Okay, let's erase this check and keep on going. All right, now I have another set of ratios. I didn't leave myself very much space there. Well, that's not going to stop me from factoring. Let's look at this trinomial. I know that the value in the first term, again, is going to be 3x and 1x because 3 is prime. So 3x and 1x. I'm going to have to squeeze it in here. Now, when I look at the 10, my options are 1 and 10 and 2 and 5. Well, let's look below and see if there's any common factor here that maybe I can create. Well, I have a 3x plus 2 here. Maybe this is going to be a 3x plus 2. And I try to keep that in mind when I'm looking for factors. If I can possibly create a pair that matches, that would help me to reduce in the end. So, let's see. If I were to make this a positive 2 and put my 5 here, that means I'm looking for values that their product is negative, the larger, which is negative. So if this is my 2x and this is my 15x, one of these has got to be positive, one has to be negative. The larger of the two is going to be negative. So 15 is my larger. That sum is negative 13x, which again is what I was looking for my middle term. So I'm going to squeeze this up here. I'm going to have a positive 2x and a negative 5. Wow. Last combination. Values that are going to give me 2x squared. That is going to be a 2x and a 1x. Factors of 6. 1 times 6, 2 times 3. Again, let's see if I can create a binomial that possibly matches a binomial in the numerator. Well, here you go. Here I have a 2x plus 1. Possibly, I can make a 2x plus 1 out of this one. Let's give that a shot. All right, 2x plus 1. So that means I'm looking at this number combination. I would put the 1 here and the 6 here. Now I know that one value has to be positive, one has to be negative, but the larger of the two is going to be negative. This is going to give me a 1x. This is going to give me a 12x. One's positive, one's negative. The larger is negative. So if this is my positive and this is my negative, that sum does give me negative 11x, which again is what I was looking for. So that means the plus is going to go in front of the 1 and the minus is going to go in front of this 6. Okay, let's try to reduce. Where are my common binomials? Now, if you think about what I was doing before, I was using binomials in the numerator and the denominator to help me factor the remainder trinomial. So I know I have some common terms. This x plus 2 is up here and down here as well. I have a common x minus 4 binomial and a 3x plus 2 binomial. So my remainder factors, my two binomials that are left, are x minus 5 and x minus 6. Now, since I don't have the exact same binomial in the top and the bottom, this is going to be my reduced ratio. Next up is dividing. Let's see what happens when I divide the rational expressions that we are given. Now, first thing we always do when we factor is take out a greatest common factor, and I see a GCF in several terms here. If I factor the values or polynomials in the first ratio, I have a 4y that is in common. That is going to leave me with a y plus 2. And again, we always want to go back and check. 4y times y does give me that 4y squared, and 4y times 2 also gives me that 8y. Can never hurt to take a little extra time to check. Okay, let's look at our denominator. My GCF here, they are even. I'm going to try to take out a 16. If I take a 16 out of my first term, that's going to leave me with a y. If I divide my 112 by 16, that's actually going to leave me with a 7. Wait, hold your horses here. This is a division. So when we divide two ratios, we need to remind ourselves that we are actually multiplying by the reciprocal. And the reciprocal of this second ratio means that I'm going to flip this fraction or interchange the numerator and the denominator. So let's make this a multiplication. I'm going to copy this over just so I don't mess myself up. X cubed minus y squared minus 6y. And my numerator now becomes y squared plus 4y minus 21. All right, just for sake of organization, I'm going to rewrite my first ratio. And then let's factor our second one. I'm given this trinomial. It has a leading coefficient of 1. We always love when there's a leading coefficient of 1. Makes the factoring a little bit nicer for us. So two values that are going to multiply to give me a 1y squared is going to be a 1y and a 1y. When I'm looking at this 21 here, I'm looking for values that multiply to 21. 1 times 21 and 3 times 7. Now, let's think about what we did with the last problem. We used the factors in that first ratio to help us factor our second polynomials. So let's say I give this combination a shot, the 3 and the 7. And I'm choosing that because down here, I have a y plus 7. Maybe that's not going to work. It's worth giving it a shot. Okay, so let's check. If I have a y and a 3, and then a 7 as well, I'm looking for two numbers that multiply to 21. One has to be positive, one has to be negative, because that's the only way I'm going to get a subtraction. The larger has to be positive. Here's my 3y and my 7y. The larger has to be positive. Now that sum is going to give me a 4y, and that is what I wanted up here. Super exciting. So I've got my minus 3 and my positive 7. I'm going to replace those operations or write those operations up here in my ratio. All right, the polynomial that's left in the denominator, this guy over here, I do notice that it has a GCF. So let's start by factoring that out. If I have my y cubed minus y squared minus 6y, let's take that common y out in front. Again, I love to factor when the leading coefficient's 1, so let's give this a shot. I know I'm going to have a y and a y. I'm looking for numbers that multiply to 6. 1 and 6 and 2 and 3. Let's use one of the factors above. See if that can help me a little bit. 2 and 3. Well, I'm not sure if this is going to work, but I do have a y plus 2 and a y minus 3. Might not hurt to try that combination. Again, it's not always going to work, but it's worth a shot. So if I use a 2 and a 3, I know one has to be positive and one has to be negative. For its product to be negative, the larger has to be positive. Here's my 2y. Here's my 3y. 1 plus 1 minus. The larger is minus. That sum gives me a negative 1y, which is what I wanted. It means it's going to reduce really nicely. So I'm going to have a positive 2 and a negative 3. Let's write this up in our ratio. So I'm going to have the y in the front, y plus 2, y minus 3, and now it's time to reduce. So you can see in this lesson, primarily, we are factoring. Lots and lots of factoring. All right, where are common binomials? I have a y plus 1 in the top and the bottom. I have a y minus 3 in the top and the bottom. And a y plus 7 in the top of the bottom. That only leaves me with a couple values left. I have this 4y, another y, and a 16. Let's write those separately. If I look at that combination now, I have a 4y in the top, that's a monomial, and a 16y in the bottom. Well, when I look at that, I can reduce that as well. I do know that y over y would reduce to 1, and 4 over 16 is going to reduce to 1/4. So that whole combination of ratios is going to reduce to 1/4. Holy smokes, that was a lot of work. Time to work with a complex fraction. Now, a complex fraction is a ratio that has a fraction in the numerator and a fraction in the denominator. Now, these aren't really that tough because this symbol is really representing division. So I have the ratio in the numerator, and I'm dividing it by the ratio in the denominator. Let's write that horizontally. I have the ratio in the numerator, and I am dividing that by the ratio that is in the denominator. Now let's think what we just did with the previous problem. When you are dividing, it means really you are multiplying by the reciprocal. So I'm going to take this ratio and interchange those terms. That is going to put the 8 in the top, and that is going to put the a squared minus b squared in the denominator. Let's factor. A plus b, that binomial does not factor. Nothing I could do with that 4. Also, the 8's going nowhere. The denominator here is a difference of squares. That's going to leave me with x plus b and x minus b. Well, if I compare my numerator and my denominator, I can see that this a plus b is my common binomial. Let's rewrite the values we have left. In the numerator now I have an 8, and in the denominator I have a 4, a minus 4. Well, if I'm looking at my numbers here, 8 divided by 4 can reduce to 2. So now I'm going to be left with a 2 in the numerator and an 8 minus 4 in the denominator. Last problem. Let's try to tackle this application. The length and width of a rectangle are provided in terms of V. Find the area of the rectangle in terms of V. Okay, well, we know when we're focusing on rectangles that you either can write this as length times width for my area. Also in geometry, sometimes you see it as base times height. Well, this one's referring to the length and the width, so I'm going to use this formula. The length of this rectangle is v squared plus 9v plus 18, and the width is 8v minus 56 divided by 8v plus 48. So let's make those substitutions. My area is equal to my length, v squared plus 9v plus 18, all over 8v squared plus 24v, and I'm timesing that by the width, 8v minus 56, all over 8v plus 48. All right, easy peasy. When you multiply two ratios, your job is to start off by factoring. Let's start with the trinomial in the numerator of the first fraction. I have v and v. In order to get the 18, I'm looking for numbers that multiply to 18. What does that give me? 2 times 9 and 3 times 6. Numbers that multiply to 18, but they're going to add to give me a 9v. I'm going to choose this combination. Numbers that multiply to 18. All right, so let's say I do a 3 and a 6. I know that they have to multiply to give me an 18, and their sum is going to give me a 9. This means they're going to be the same sign, both positive. All right, let's say I make these both addition, and let's give this a shot. My product here is going to be 3v, and this product is going to be 6v. Same sign, both plus. I really like x for some reason. Let's go back. 6v. Same sign, both plus, means that sum is 9v, and that is what I wanted. So I factored that first one correctly. Let's look at the denominator of that same ratio. Well, I'm going to take a GCF out. I see that they are both divisible by 8 and both divisible by v. Well, if I take that term out of my first term here, that's going to leave me with a v. And if I divide this 24v by 8v, that's going to leave me with a 3. And already I'm excited because I see a binomial in the numerator and the denominator that match. All right. Is there a GCF here? Is 56 divided by 8? Good question. I'm going to take the 8 out and give it a shot. If I divide 8v by 8, that gives me v. 56 divided by 8 does give me 7, so that's a good start. Same process with the denominator here. I see another greatest common factor. If I take the 8 out, that's going to leave me with a v, plus 48 divided by 8 is going to leave me with a 6. So now let's reduce. Are there binomials that repeat? A binomial that is in both the numerator and the denominator will reduce to 1. Here I have a v plus 3, that's gone. Here I have a v plus 6, that's gone as well. And we have one more common term, 8 over 8. This reduces to 1. This is a great problem. So I am left with the binomial v minus 7 in the numerator and 8v in the denominator. So this expression represents the area of the rectangle. Have a great day, everybody.